So just to introduce ourselves, so I'm Neil Strange. I'm the CEO of Data Vault, specialist in data platform development. We like Data Vault, we like data mesh, we like other methods as well, like Medallion. But primarily, well, my background is I'm a scientist, physics graduate from London University. I've been in consultancy for many years, both management and IT consultancy. And that's why I like BI, because it kind of straddles both worlds nicely. I'm also a specialist in data platforms and analytics. Jeff, would you like to introduce yourself?
Yeah, hi everyone, Jeff Hodgkinson. So I'm a solution strategist at Erwin by Quest. Been there now for 5 years. So I've worked with all sorts of data modeling techniques over the years, and not just data modeling, but data integration, data governance, etc. So I'll be supporting Neil during the presentation today.
Thank you. We're short on time. So what we suggest is if you have any comments or want to ask any questions, could you please put them in the chat? And at the end, we'll get back round to them at the end if we have time. If we don't, we'll try to answer them offline for you, off you anyway. So just to remind you, data mesh has 4 principles: data as a product, domain-driven ownership of data, federated computational governance, and self-serve data platform. And essentially, we're doing 4 webinars, one on each of these principles. And today, we're going to focus on the domain-driven ownership of data. Now, domains is an interesting topic. I mean, it's come out of domain-driven development, the Eric Evans approach to developing application software. But it's new in its application to BI and analytics. Now, to be honest, in the history of data modeling and so on, we've always had the concept of data subject area, where we build a larger data model from components. And there's a lot of overlap and correspondence between data subjects and domains. It's just that domain is possibly the more modern word for it. So if you look up the definition of a data domain, it's essentially a specific area of business functionality around which data is organized and managed. So we're data modeling, we're collecting data linked to a business area, business functionality area. In data mesh, the concept of domains allows you to have a number of teams all working in parallel across a kind of federated structure. And to make that work, the domains are given a dedicated team. So a team might look after one domain or more than one domain, but they're totally responsible for the data products that come out of that domain. So they look at the management of data, the metadata there, policies for managing their own data, and they are accountable also for their data. So they're accountable for meeting any data contracts that are in place for the products that go out. And the theory is that having a number of teams working in a sort of semi-independent way, you get greater agility and scalability in your architecture and much more efficiency in data management. Now, I think there's a case for that. I'm not totally convinced, to be honest, because there are special things about data that make it difficult to chunk it up and make it work as a coherent set. But anyway, it's a very intriguing and very interesting way of getting through the bottleneck that is the centralized BI team. Now, all the pillars depend on each other, all the principles depend on each other. So if we put domain-driven ownership of data right in the middle there, essentially, when data leaves a domain, it leaves as a data product, and that's where the data as a product pillar comes in. When data leaves a domain, it has to be wrapped up as a product. You need federated governance to make sure all the domains are kept in line with each other. So there might be principles for how we identify what a domain is, and we might have standards for interoperability and the design of a domain enforced by governance. And then finally, as domains are created, it's going to be very expensive to have the best qualified engineers, data engineers in every domain across the organization. So you need to be able to support teams there who may not be as expert as normal in the work that they do, and that's where tooling comes in. So being able to support them with pre-canned configurations for development or deployment in their self-service data platform. So they all depend on each other, all these pillars, and domain-driven ownership is not isolated. So what I'm going to do, I'm going to take you through an example. I'm going to look at a hospital, running a hospital. That's a definition of hospital. I'm sure you don't need to read that, but it talks about the purpose of a hospital, why it's there. And what we're going to do is look at the analytics necessary to support running this hospital, and we're going to focus right down on a particular use case in there. So the first thing we need to do is we need to understand the operational capabilities of a hospital. So this is the ability to run a hospital, means we need to have abilities across all of these areas to drive the management of that hospital. We need to have the ability to manage healthcare services, to deliver emergency care, and so on, as part of the operation of that hospital. And as you question might be is, well, why do we want to look at capabilities? Well, the capability is the ability to do something. Okay, the ability to run a hospital, the ability to run an emergency service, and so on. And you can express those in a way that's independent of implementation detail. So these are sort of fundamental things that the hospital needs to be able to do. And capabilities therefore change less frequently than the business processes and systems and structures underneath. And it makes them a great candidate for the domains that you're going to need inside your data structures there. So capabilities are essentially domains. And what we can do is we also are aware that within a hospital, there's probably hundreds of systems working there. The big one being the electronic patient record system, but there's finance, there's HR, decision systems, clinical systems, and so on in there. And I've typically seen 450 or more systems running in a hospital, many of which might feed the need for analytics there. And what we're going to do is we're going to start off by looking at the capabilities we had. Now, remember the top level model we showed, that's shown in the back here. We can drill down inside that. So, for example, inpatient care breaks down to a whole set of sub capabilities. And within there, there's sub capabilities. And of course, a hospital is a very large organization. So you might expect there to be a significant number of capabilities in there, which can all be managed independently of each other, and all of which needs analytics input to run efficiently. And what we're going to do is we're going to have a quick look at the patient admission and discharge capability, which itself is within the inpatient care capability, which itself is in the ability to run a hospital. So you can see we're drilling right down here. So we're looking here at admission procedures for non-elective admission. That means emergency admission, and the discharge planning. So planning for freeing up beds for new arrivals into the hospital. So we have, first of all, running the business. So we have an operations plane. And that's where the business is basically operating and running the business. And there'll be a number of systems in there being used by the business processes to allow them to deliver the operational part of the hospital. So here we have the capability to admit and discharge patients. And to do that, we need data from all kinds of areas. So we need to know what patients we have in the organization, if there's any ambulances arriving, whether there's patients in transfer between wards in beds and wards in the hospital. And we also need to know if there are free beds coming up and where they are in the hospital to do this sort of real-time admission of non-elective patients. And of course, there are lots of capabilities inside a hospital, and those capabilities might share the use of some of these systems. So the electronic patient record system is used widely across the hospital. There'll be lots and lots of capabilities that work with that. But there'll be other systems in there like management of ambulances while on site, and maybe porters as well, portering services. So there's like a chain here of abilities collaborating with each other inside the hospital, all using a set of systems to coordinate the data underneath for operational reasons. Now, data mesh talks about separating your analytics into two layers. There's the operational layer, which is the running of the hospital, and it's for real-time transactional data. And then an analytics layer, which is where your aggregated and conformed and cleaned historical data is used in place. And the reason we separate them is they have different architectural needs. So operational is about real-time transactions, and the analytics layer is about aggregation and conformance and cleaning and representing the data. So they have different needs for scalability and flexibility and governance. So we end up with these two planes. So we have the business operations plane, which is where our systems live, and we have our analytics plane where our analytics data live. And those are all divided into domains. We have system domains underneath, they're more physical. And we have analytics planes on top, fed from the operational data and used to do analytics within that domain. So here's an example of the source data coming in. So we have three source systems here on the left. We have an ambulance perimeter monitoring system, electronic patient record system, and a porter service. And they are generating data to feed into our analytics area. These are source domain data products, and they feed into our patient administration and discharge decision support system. That's an output from our analytics layer. So let's just have a quick look at the admissions and discharge. Okay, so this is an interesting part of the hospital. It needs to have data from all kinds of areas to build up a picture of where patients are and the status of them for admission purposes. So they need to get status data from a range of different systems. So patients arriving in ambulances, where they are in the system at the moment, if they're being moved from one place to another, and so on. And that's very important because we're then moving into having data to analyze that process to support it. Here's a concept model. This is a concept model of the analytics necessary to run this capability inside the organization. As you can see here, we have physical information about the hospital, the sites and the wards that are there. We have beds which are being subject to preparation and so on, and then patients being admitted and discharged into the hospital. If you drill down in here, you find that actually that data belongs to a number of different domains. So you can see here, porter service is right in the middle. You could imagine that there is a team responsible for efficient portering. There's a team responsible for efficient housekeeping, a team responsible for ward management, and so on, all focused on their own data sets. And we need to piece these together when we want to look at admissions and discharges, which is on the far left here. So we need to be exchanging data backwards and forwards between different analytics teams to support the decisions around the patient admission and discharge. We need to be receiving data products exchanged between these domains. And we can also add to the mix external data sources as well. The ambulance service may provide information about inbound ambulances, and the local government might provide information about community beds for people who can be discharged back into the community. So external data as well coming in to support all that planning work. We're kind of left there with then some challenges. So the first thing is we need to be able to model our source domains. So we need to understand the data that's available from our operational systems. So to do that, we need to be able to scrape the schemas and identify keys and so on in there to build up a picture of the data that we're receiving. But then when we go inside a domain, we need to know the sort of conceptual items inside that, and maybe a logical model of the data that we have within a domain. And finally, when we share data out in the analytics layer, we're sending these data products backwards and forwards, and we need to make sure we've got common terms and definitions used there, a kind of canonical model across the top, so that these data products all fit together and provide data in the correct way. Now, for example, common use of primary keys needs to be enforced at this level. So essentially what I'm trying to show here is we've got the products on the left that we can be sending out, but they include fragments of data from the hospital, which could be standardized. So for example, our patient move report would have information about beds and chairs and wards and clinics in it, and we should be representing beds the same in other data products that also include bed data, and we should have a common way of representing bed information and patient information, which is what that canonical model is all about. So just to add to that mix as well, we're going to have data teams in a number of places. So the data teams in each domain should be fairly small and productive. And they're basically we would have a lead engineer in each team with data engineers, testers, and so on in there, a mix of skills. And they would interact with sort of security platform engineer and may have a sponsor for the work that they're doing. And as we're working across multiple teams, we would move out to something like this, which is based on the team topologies approach to design. You'd see across the top there, we've got a number of delivery teams. We would have potentially a center of excellence in the mix, whose job it was to promote good practice across those teams and to enforce standards and so forth. Platform team providing the self-service platform that the teams will be using, and governance as well, very important across the top, making sure everything fits together. So that's a quick run through of what the challenge is in there, and really the questions we have in there as well. How can we best understand all those source system data schemas that are coming in so that we understand the source domains? And then when we're inside a domain, how can we work on the data models necessary at conceptual and logical levels? But then not only that, but how can we then scale that up to have multiple teams working together on one data model and enforce things like data visibility so that teams are working on data within their own scope? So Jeff, sorry, been talking too much. Maybe I'd like to bring you in here because this is a sort of challenge you see at scale. It's all very well having one team doing this, but when you've got multiple teams working together, it starts to get very interesting.
Yeah, absolutely. And the challenges here, I mean, this is a good example with the hospital approach, hospital example, but there are other examples out there. I remember working with a large logistics company which had multiple different uh, acquisitions from smaller logistics companies from multiple different countries, and they each had their own view of data models, view of the definitions for conceptual logical objects. And it was always a challenge there to integrate them all together into anything which was even remotely coherent. So
Yeah.
from my perspective, there's aspects here from data modeling. You want to be able to create data models at all levels here, conceptual, logical, and physical. And also the work you then do with your data models should then also be intrinsically linked with your business glossaries, your taxonomies and ontologies, how a concept like a patient can differ or be common across different operational areas of a hospital, for example.
Yeah. Okay. I agree with that. Yeah. I mean, one of the sort of challenge I find is the ability to ensure commonality across teams. So they're all off modeling their own areas, but you want to maybe enforce some naming standards or layout standards in there to make sure that you can review across team and so forth. How can Erwin support that?
Yeah, so you're quite right. I mean, some people take the view of the data mesh can be a little bit like the Wild West, where each business domain is doing their own thing completely independently. But the fact is, there is still a lot of commonality to be found. So that commonality can be defined within your data model. So I'm just going to share my screen if that's all right,
Yeah, no
and
trouble. You take control. It's all right.
and show an example of a model structure. So this hierarchy here is each colored box in here is a data model. So we've got the various different layers in here. We've got conceptual layers, we've got logical layers, we've got physical layers. So up the very top of this, we would have a very high level conceptual model for a hospital. And there are going to be common objects in there, such as a patient. Patient has a name, patient has an ID, patient has an address and a NHS number, like a healthcare number or ID, those kind of things. And that can be then shared or common with all these second tier, in this case, potentially logical models. And we were talking about one particular area. So let's focus on here on the inpatient care. So that's inheriting that patient definition. But then you could also inherit various objects down to outpatient care. So that patient object would be the same, with the same definition, same properties, maybe some subtle differences, but inpatient care, you're going to be linking in with the portering service and the admissions and discharge, whereas with outpatient care, you've got no need for the portering or the admission and discharge. So they can all start to separate out into their uniqueness at that level. And then you can go to as many levels of this logical design. So here, I've just kept it fairly simple. I've got a third tier in there for admission and discharge, which belongs to inpatient care. And then you can have fourth tier, fifth tier, sixth tier, all the way down to where you actually get the raw data in some database somewhere. And it might be several databases. So here, we've got Oracle and Postgres in there. And you can attack the documentation of this from any level. You can start at the very top and have some team responsible for the conceptual level model, have another team potentially responsible for inpatient care and everything under inpatient care, and then have your data engineers all the way down the bottom, just dealing with the actual raw data. They still need to know the definitions, and that can be accessible through a well-designed data catalog and business glossary, etc. So they can have the access to the actual context. What am I dealing with here? I'm not just dealing with data, I'm dealing with real people and real concepts and real capabilities. And also reverse the whole thing. People at the top at the conceptual level have the access and the visibility of where this data actually is. How can we go and attack this data and produce a data product for the type of analytics we really need?
I agree. We were talking a while about this, I think, yesterday, preparing for today's presentation. I think being a hospital example here is a bit of an accident, if you say, in terms of how this analogy goes. But there is a debate around, well, if we have domains, surely they should just work on their own, on their data, and worry about integrating it later back into a larger picture. When if you needed, for example, to have an analytics domain which was aggregating a lot of data together, just like the example actually here. And I like to think about data in this way. I think data adds no value to an organization unless it's flowing. And the reason for that is if it's flowing, someone's working on it, they're making use of it, and they're adding value. So every action you perform in an organization takes data, does something to it. While you're working, you might capture information and then you're writing it somewhere. So what you've done in the organization is represented by a flow. If data just stays static, no one's working on it, it's just there. And okay, it's a record of what happened. It's a record of the flow. Now, so I can imagine, if flow is important for the life of the organization, it's a bit like a hospital patient in a way. The flow of the blood around the patient is also very important to keep the patient alive. And having multiple teams working on modeling is a bit like having multiple surgery teams all working on a patient on the same slab, and that you need someone monitoring the patient at the top, i.e. governance, whose job it is to make sure the patient's still alive, and then the anaesthetist is working on pain relief and making sure the patient's out, of course. But the teams need to coordinate on this living thing. Now, if obviously it's easier if the teams just cut the bits off the body and take them off to a different part of the operating theatre and then work on them independently. And it's a bit like that with data. You've got to realize it's joined together. There's common primary keys and things flowing through the system. And therefore teams need to work on essentially one data model, but controlled in a way that they have their own part to work on, and they don't stray and interfere with each other as they're working. And that, I think that's the challenge, really. You've got to understand you are working on one big data model. You can't completely decompose it into isolated elements. But at the same time, you need to be able to coordinate and make sure that they work together on the patient. I found that quite a useful one. I don't know about you, but I think that's a nice analogy.
Yeah, absolutely, and it reminds me of when my wife gave birth to our twins. About 20 different doctors and nurses all in the theatre at the same time. One person was coordinating the whole activity, but each doctor and nurse had their own specific thing to worry about: the anaesthetist and the person to take the children out after the cesarean and monitor each of the twins afterwards. So they all needed to work together, but they each had their own domain expertise that they're responsible for.
You've basically gone back through some of those challenges. I think if you look on the market, there are very few data modeling tools out there that work with multiple teams. And erwin data model has been around for such a long time. It's a staple part of any data modeling team that's out there.